Right. Good evening, everyone. Last week we completed chapter 1. Now today we start chapter 2, that is physics unit 2, right? So chapter 1, there are two questions, a set of questions, structured essays left. I'll discuss them today. And we start physics unit 2, grade 10 today, right? So I have posted both textbook PDF as well as theory tutor PDF to your WhatsApp group, right? Okay, then I'll share the screen. So this is unit 2 physics grade 10. Before we discuss the motion is the topic of the lesson, motion in a straight line. You can see the screen now, right? Okay. And unit 1, chemical basis of life, we completed all the MCQs and this lesson. The lesson also done, and MCQs also we discussed, and the structure is also one question I discussed, right? So we had to start with structured essay, last two questions of this paper. Actually, they have given this in the provincial paper, those two questions. Look at the screen. Please raise the hand those who have answered this question. Question number 2. Question number 1 we discussed last week, right? Yeah. Question number 1 we discussed last week. Question number 2 we had to discuss today. Please raise the hand those who had answered this second question is structured essay. How many of you have done this? Please raise the hand those who have answered chapter 1 theoretic the questions. Only 5-6 students. What about the others? Okay, 7, right, good. Those who have answered well, very good. This is actually they have given this question 2018 Western Province first term test paper. You are given some string hoppers, egg curry, banana, milk tea for breakfast, and based on the above food items, fill in the blanks given below. Right. So they asked to find the food item which contain protein and the main nutrient in banana, and chemical needed to identify. Please raise the hand those who forgot this and couldn't answer this. Please raise, be honest. Those who forgot this question, that these two questions to answer, therefore couldn't do this, please raise the hand. The last two questions of the theoretic. Anyone of you have not done, please raise the hand. Those who couldn't do these two questions, the last two questions of the theoretic. None of you, all of you are done. Okay, then you have to give me the answers when I ask you to unmute, right? Okay, all of you are done this, ne? Right. Please raise the hand those who have answered this question number 2 part A. Yes, part A. What is the food item which contain protein? Yes, any volunteers? Yes, Hiro.
Egg curry.
Kishan, Adhika.
Egg curry.
Yeah, very good, all of you are correct. Answer is egg curry. Answer is egg curry, right? Those who are done, you can mark with a red pen. It's egg curry. The next one, banana. Then one more thing, chemical needed to identify this. The chemical needed to identify this. Yes, who can give me the answer for this? So the main nutrient protein, what is the chemical needed to identify this food item in the egg curry? Egg white contain protein. Any volunteers? Chemicals or chemicals? So like actually protein, you have to use two chemicals. So please, yes, Hiro, Bhatika, Rohini.
Copper sulfate.
Sir, sodium hydroxide
and copper sulfate.
Very good, very good. Sodium hydroxide and copper sulfate. Okay, write the answer. Those who are done, you can mark with the red pen the answer. I'll write here the formula NaOH, sodium hydroxide, and CuSO4, copper sulfate. So these are the two chemicals that are used to identify protein present in a food sample. Copper sulfate. If you want, you can write the answer in words, no problem. If you want, you can write the answer in words, no issues. But you can write the answer using this formula also, right? The next one. Banana. What is the main nutrient present in banana? Yes, any volunteers? Banana, ripened banana. After eating the breakfast, you take the dessert banana. Okay, Satsarani, Bhatika, Sandusha.
Vitamin E. Glucose.
Okay, actually they are asking about the carbohydrate mainly. Main nutrient means, so there are 4 major nutrients now in your diet: carbohydrate, protein, lipids. So which carbohydrate present in this? Again, please raise the hand those who can give the answer for this one. Banana, what is the, yeah, vitamins also present in it, but they have given chemicals need to identify that nutrient, then you can't write vitamin. Yes, any volunteers? Sandusha, Bhatika?
Fructose. Fructose.
Can you repeat again, Sohana? Kishan?
Fructose.
Bhatika?
Fructose.
Monosaccharide.
Yeah, actually there are 3 monosaccharide: fructose, galactose, and glucose. So here you can write fructose. Yes, very good. Ripened, it's called fruit sugar. So what is the chemical needed to identify this? Yes, what is the chemical needed to identify this? The last, next blank. Any volunteers? Sandusha, Hiro?
Benedict solution. Benedict solution.
Benedict solution.
Very good, all of you are correct. Benedict solution. Okay, those who are done, you can mark with the red pen the answers. Theoretic chapter and questions before we start today's lesson. Benedict solution. Right, next one, name the food item that contains disaccharide from the above list. Which food item contains disaccharide? Number 2, part 2A, the answer. Yes, any volunteers? Sandusha, Satsarani,
Milk tea.
Sohana,
Tea.
Hiro.
Milk tea.
Very good. Milk tea contain disaccharide. Actually, that is lactose. Ne? Yes, milk tea contain lactose. That's a disaccharide. Very good. All of you are correct. Answer will be lactose. I'll write the answer here. Lactose. Excellent. Lactose. Next one, B. Name a type of disaccharide in the food item that you mentioned above. Name a type of disaccharide in the food item that you mentioned above. Name the this one you had write here, not lactose, sorry, that you had write milk tea and then you had write lactose. Yes, okay, sorry. This is milk tea. Milk tea, it contains lactose. So I gave the answer for the part B, lactose present in milk. Actually, if you are drinking milk tea, powdered milk with mixed with sugar, that means you are getting too much carbohydrate. Milk also lactose. So actually your milk tea, if you are drinking milk tea, it contains 2 carbohydrate. It contains lactose from milk. Look at this. Your milk tea, your bed tea contain what? Milk tea consists of 2 disaccharides. Milk tea consists of 2 disaccharides. Milk tea. One will be lactose and the second disaccharide will be sucrose. Why? Because to lactose is no sweet taste. Lactose no sweet taste. That's why you need to add sugar. Sucrose means the white or brown sugar that you eat. Both are disaccharide. You can write. Please make a small sketch of this diagram. This is very interesting. Milk tea contain 2 disaccharide. Lactose come from milk and sucrose come from white or brown sugar. So after eating string hoppers bread, if you are drinking milk tea after eating bread, no wonder the people in Asian countries will get diabetics. Why? Bread also carbohydrate. After that you eat milk tea, and after that if you are eating ice cream, all this carbohydrate, too much sugar, the body cannot handle that, cannot tolerate it, that high level of glucose, carbohydrate, simple sugars. Sucrose, that means white or brown sugar. White or brown sugar. White or brown sugar. Right, that is sucrose. Okay, both are carbohydrate. At the end, what is absorbed to your body? Excess carbohydrate. Right. Part B, I'll erase the screen. Part B. Protein is an important component in all living cells. Protein perform important role in the living bodies. Name 4 major elements present in 4 main elements present in protein. Okay, very simple question, B1. Yes, any volunteers? Sohana? Satsarani?
John.
Carbon,
On.
hydrogen, oxygen, and nitrogen.
John.
Yeah, okay, Satsarani. Yeah, John, but in the exam don't write John, but I mean, C, comma, H, comma, O, comma, and John. Yeah, the short method is John, but you have to write the symbol of the element, or else you have to write the answer in words. Carbon. That's why I think she told John, carbon, hydrogen, oxygen and nitrogen. These are the 4 elements present in any protein. Sometimes sulfur also could be present in protein. So proteins are made of these 4 elements. Proteins are made of amino acid. Amino acid also consists of the same element, carbon, hydrogen, oxygen and nitrogen. Then what are enzymes? Yeah, what is they have given that in the textbook also as a definition. What are enzymes? Yes, anyone can define enzymes. Enzymes, your saliva contain enzymes, germinating seeds contain enzyme, your digestive tract, there are so many digestive enzymes. Yes, Hiru, what is the definition of enzymes?
Enzymes are special proteins that produce within an organism to increase the rate of biochemical reaction.
Okay, very good, excellent. That is the definition of protein. Please copy down those who are not done. Special proteins produced within the organism and increase the rate of biochemical reaction. What are enzymes? Is special proteins. Special protein, and they are organic. Special proteins that are produced within the organism. Proteins produced within the organism to increase the rate of biochemical reaction. Within organism to increase the rate of biochemical reaction, rate of respiration, rate of digestion, to increase the rate of biochemical reaction. That means how fast something happen. That means rate of digestion, rate of excretion, all this, rate of various synthesis of protein in your body, lipid, cholesterol, to increase the rate of biochemical reaction. Chemical reaction taking place in the body called biochemical reaction or metabolic activities, biochemical reactions. Again what? Special proteins produced within the organism to increase the rate of biochemical reactions. Special proteins produced within the organism to increase the biochemical reactions. Actually all the enzymes are protein, as well as all the proteins are organic. Therefore enzymes are also organic. Number 3. What is the product formed due to the action of amylase on carbohydrate? When amylase act on carbohydrate, what is the product you get? So when amylase act on carbohydrate means you can write here within I think mainly the starch. You can write within the starch here. When amylase act on the starch, I mean carbohydrate will be the starch here, right? Within bracket you can write starch. Actually that is it should be a starch here. When amylase act on starch, what is the product form? Any volunteers? Yes, Rohini?
Maltose.
Very good, Rohini. Answer is maltose. The product will be maltose. Maltose. Example, when you bite some rice inside your mouth for few minutes, you get a sweet taste because of the production of conversion of starch into maltose. Conversion of starch into maltose, right? Then next one, part 4. What is the substance that produce okay, to amylase enzyme? If amylase enzyme is not available, what is the substitute you can use? When amylase enzyme is not available, what is the substitute we can use? Yes. What is the substitute we can use? Can anyone tell me? Imagine normally laboratory the amylase enzyme is present, but if it is not available in your lab, then you cannot continue the practical and you cannot do the practical. Then what is the alternative? They ask. Any volunteers? Okay, only 2 students raise the hand. Yes. Hiru?
Copper
Batika?
sulfate and sodium hydroxide.
No. Amylase? Yeah,
Saliva.
chemical. Yeah, what is Batika?
Saliva.
Saliva. Other than saliva, anything else that we can use? Any other volunteers? It's given in a textbook. It's given in a textbook under the practicals. None of you. I told this name. Look at your textbook page. Wait, I'll show you. First lesson, there's a practical here under protein. Protein, this one. So this is the practical. Amylase here. Activity of amylase on starch. Please put 3 stars. This very important practical. Mostly remember your grade 10 and 11 textbook. Each lesson you get activities like this. Activity 1 here. Activity on. Please put 3 stars in your. If you have, I gave the PDF also. Those who have not got the textbook, I forwarded the PDF of chapter 1 and chapter 2, the PDF of the textbook, right? So then you can, if you have got a printout until you get the textbook from the school, you can use them only for the first 2 lessons until you get the, yeah. Can you see here, amylase, how to get filter, here, this one. Can you please underline this? I'll highlight this pink. No one gave the answer for this. You can get amylase enzyme, 2 milliliters of amylase you can get, how? By using solution of ground. The ground means like you have to grind germinating green grams or mung and mix it well. That means what? We call it mung germinating mung seeds extract of the germinating mung seeds. So this is the alternative if the amylase enzyme is not available in your school laboratory. Please underline or highlight this. What is extraction of germinating mung seeds? Extract of, that means you crush it or you grind it with water and you filter that and get this solution. Extract of germinating, that means you soak mung seeds overnight and next morning most probably the seed could get burst and then the seeds increase in size, they begin to germinate. Extract of germinating mung seeds. Extract of germinating mung seeds, right? So that is the one we use, the extract of germinating mung seeds, or even any other green gram, or yeah, you can use. So as you said, if you want, you can wash thoroughly your mouth with water and then saliva. Salivary amylase also they are, but I don't recommend this I don't advise, because these days I don't think anyone is willing to do this because of COVID. No, you are using the mask, even teachers won't allow you to remove even mask, right, during the school. So therefore now But without COVID-19, if there's no pandemic situation like this, then you can go for this also. Salivary amylase also can be used as a substitute, right? Remember, amylase enzyme is available as in your school laboratory. No need to use extract of germinated mung seeds or salivary amylase. If it is not available, then you can go for one of this, right? Salivary. You can wash your you can take some water inside your mouth and you can mix that with saliva well, and then you can take it out into a test tube or beaker. You can use in a dropper. You should not contact that, or else you can go for the best one is this germinated mung seed extract. Why? Please put a stand, write in your short notebook, amylase enzyme present in saliva and germinating seeds. Please write it, write with a red pen, and put 3 stars near this practical in your textbook. Activity page number 9, activity 1, page number 9, activity 1. Very important, not only for the school term test, all level papers. So far they have asked this question in past papers, so this very important in upcoming papers. Put 3 stars with a pencil at least. Those who have got the printout, please raise the hand. Those who knew this amylase enzyme present in saliva and extract at least one of these germinating mung seeds. Those who knew this before, I told this when I was doing the theory. So you have forgotten this. It's very important. These are the areas where you get questions. I will write in. Okay. So again, what? Amylase enzyme present in the germinated mung seeds. So therefore you can grind it with water, the germinated mung seeds, and then you can filter it and get the solution or suspension. Right. I'll move back to, I'll erase this. I'll move back to the question now, theoretic. Right. So what is the answer? What is the substance that can be used in the laboratory? Substance that can be used in the laboratory when amylase enzyme is not available. So write there saliva, or you can write extract of germinating mung seeds. Germinating mung seeds, so germinating seeds, or green grams, or just write extract of germinating seeds. Germinating seeds contain enzyme. Why enzyme amylase? The seeds contain, now we are eating rice, right? Rice contain carbohydrate, that is starch. Potatoes contain starch. Sweet potatoes contain bread, right? Manioc, string hoppers, all this starchy food. So you cannot directly absorb that the starchy food directly into your blood from the intestine. So that's broken down by this enzyme amylase. Therefore, to digest carbohydrate, amylase enzyme is present in your saliva. Right. And not only that, mother plant store some food for the baby. Baby means the seed. Inside the seed there's a life in it. That is why when you can get new plant from the seeds by putting the seeds in the soil. So there's some carbohydrate stored in the seed for the baby to grow. Baby means the embryo inside the seed. So until it's able to produce its own food by photosynthesis, mother plants storing some food in the seed. So we also depend on that seed or the babies of the plant, right? So it's very important understanding that, right? Then back to the next one, next page top. Amylase and iodine solution was added to the carbohydrate and was kept for a few minutes and observed. In this activity, how do you identify that the function of the amylase enzyme has ended? Amylase enzyme has ended. How do we know? When amylase act on starch, it is converted into maltose. Amylase enzyme has ended. That means what? What you are mixing now, I'll highlight green. This is a very good question and it's hard. Amylase and iodine solution was added. You add iodine and amylase together into carbohydrate and you keep that for a few minutes. Actually what happened, when you look at, I use by this white, this one I put a star, very important because it's a hard question and you need practical knowledge. I don't know, I mean you have not done this practical in school. Definitely you are supposed to do this as a practical in the school. Right, look at the screen. I'll use this white background for the explanation. Right, look at the screen. Right. So initially you can make a small sketch of this flow diagram also if you want. First, what you have carbohydrate, that is starch, right? Please make a small sketch of this diagram. You take this you add here. Now you have here carbohydrate or the starch, the suspension of the solution, and to this you add in amylase and iodine. What is the color here? Brown. Brown. Why brown? Sorry, dark blue. You get the dark blue color here. Why dark blue? Or the purple? Blue, black color or purple? Blue, black color or purple? Right? So dark blue or blue, black color. Right. So what happens to this blue black color? What happens to this blue black color after adding? So actually I'll highlight. Blue black color comes so dark blue because of iodine is brown. It's getting reacted with the starch. So because of this combination. How to identify starch in the lab? When iodine combines starch, you get the blue black color. That means what? Iodine plus starch combination. Now starch is present. Now after some time what happened? This amylase convert. So this is before it's blue. Now what happened? The amount of starch gradually decreases. The amount of starch gradually decreases, and it turns into what? This is before. And after that what happened? After some time, you will not get this blue black color. You get what is the original color of iodine is brown. Iodine is brown, and with the presence of starch it becomes blue black color, right? Blue black color, right? Iodine plus starch gives blue black color before the experiment. After the experiment what happened? Now there's a reaction going on. What is the reaction going on? What happens here? Iodine and the starch, iodine no change, iodine nothing happened, but amylase enzyme act on starch, and starch is completely broken down into maltose. When this reaction is over, this is done by which enzyme? Amylase enzyme converts starch into maltose. So then at the end, no more starch, only maltose now. When the reaction is over, when the reaction completes, only maltose in the solution. Only maltose. That means all the starch converted into maltose by amylase enzyme. When the reaction ended, what happened? All the starch converted into maltose. So we have to put excess amylase. If amylase is not enough, then some unreacted starch can be left. So therefore, all the starch converted into maltose by amylase enzyme. Now we'll look at iodine is there. Iodine no change. What is there at the end? You have only maltose, no more starch, and iodine. Will iodine combine with maltose to give a color? No. Now you get the original color of iodine will be left. So you get the brown solution you will get at the end. What? Brown solution, that is because of iodine color. How do you know when the reaction is over? That's what they asked me. In this activity, how do you identify that the function of amylase has ended? When the amylase function is ended, what happened? No more starch. Right here, that means what? No starch left. No more starch. No starch, only maltose. When the amylase action is over, no starch, only maltose will be left. Then blue color will disappear and brown color of iodine will appear. Earlier, brown color turns into blue because of starch. Iodine act on starch and giving the blue color. Look at that, iodine act on starch and giving the blue color, dark blue, black color. But after that, after some time, what happened? No more starch. Why? Amylase enzyme converts starch into maltose. Then only the brown color will be left, the pure iodine. Original iodine is brown. So this is very, very important. This is a practical or the experiment you are supposed to do in the school laboratory. Most of the O-level papers, grade 10 term test papers, they are this practical, because most of the students, teachers, they don't do this practical in school. So therefore, encourage your, inform your, once you start this, the grade 11, grade 10, some of you are already started private schools, but government and semi-government schools, you will start in the grade 10 syllabus after your grade 9 third term test. Again, I'll repeat. In March, you will be getting Western Province grade 9 third term test. Now you are still in the grade 9. Most of you are in the from the government and semi-government schools. So March you will be having the your grade 9 third term test. April 18, they are giving holidays, and then after the April holidays, you will start April 8th. I think they are giving holidays, and April 18th they are going to start the new term, that is grade 10. They are going to start in schools in 18th of April, right? Until that you will be in grade 9, and after the new year holidays you are going to start the grade 10 work. But anyway, so when you start, once you start the schools, see whether the teachers are doing these practicals. So it's very, very important. If you should know the real color of iodine, right? But later I will do the practicals and I'll show this experiment, the video clip later, right? But this is very, very important. Again, I'll repeat. What is the initial color? Blue, black or violet. Why? Because of the starch and iodine. Iodine act on starch and convert. That's how you identify starch in the laboratory. But after some time, what happened? The starch is gradually, now not within 1 second, gradually the starch is getting converted into what? Gradually the starch is getting converted into what? Maltose. So this reaction you can write down. This is very important. I explain this since it is hard. I explain everything in detail. So what is the enzyme which act on the starch? Amylase. And what is the product form? Maltose. So when the amylase action is over, no more starch, only maltose. Then no blue color, it decolorizes and brown color appears. So what is the answer for this now? In this activity, how do you identify whether that the function of amylase has ended? When blue-black color of the solution turn completely into brown. Again, what is the answer for this? When blue-black color of the solution completely turns into brown, that means amylase action or amylase function is over. Why? Amylase has converted all the starch into maltose. All the starch is converted into maltose by amylase enzyme. That means what? Blue color turn into brown. So write the answer. I'll erase this. Anyone still copy down this diagram? Please copy down this diagram in your writing book, the practical. This is before, this is after. So this is after. What is the observation? Observation is color. You can't see the molecules through your naked eye. Observation is what? Blue, black color turns into brown. That is observation. Brown is only iodine, no more starch. With starch, it's blue, black. Without starch, iodine color brown. So therefore, initially it's blue, black. Later it turns brown because maltose cannot give a color change with iodine. Remember, disaccharides not given the disaccharides. We can't use iodine. Disaccharides we can use what? Benedict solution. The starch we use iodine. Right? Monosaccharides and disaccharides using which reagent? Benedict reagent. Right? Then they are blue, become brick red color. Right? Starch we identify using iodine solution and it turns brown. Very important, right? Okay, I'll erase the screen. Anyone still comment on this? Done, right? I took time and explain because you someone Sachin, you are copied down, right? Okay. Hurry up. When you're done, please lower your hand. When you're done, please lower your hand. If you have any question, you can ask, or you can raise the hand and ask any question you want. If you have any other doubts about this. Okay, done. Sachin, when you're done, or else you can take a screenshot or you can request the recording even. Please copy down. Everyone should maintain a separate short notebook for the biology. I mean, not just the answer. I gave the detailed explanation how this happens. What's going to happen. Therefore, that means what? When you put some rice into your mouth, it begins to become what? It's getting converted into maltose, but not within 1 minute because of saliva. Saliva contain amylase ne. Saliva convert rice. Rice means starch, right? That is converted into maltose. So then, because of salivary amylase, saliva contain amylase ne. So if you are keeping the rice seed for a longer time, what happened? Then the entire rice seed, the starch become maltose. That's why you get the taste, right? Carbohydrate you don't. That's why when making a milk tea or because lactose, no sweet taste, right? That's why you add in sugar, sucrose. So what is the answer for this now? How to write the answer? When blue-black color turns completely into brown. When blue-black color of the solution turns brown. So that's then you identify that function of amylase ended. That means amylase has converted entire starch, the sample into maltose. Then you will not get any more blue-black color because only maltose, no more starch. Starch has become maltose because of amylase. Right, part B. When the function of amylase is over, name the reagent that is used to identify the product form. What is the product form? I'll highlight here. What is the product form from? Who can tell me the product form from the previous experiment? What is the product form from the previous experiment? Previous part 5. What is the initial one? That is the carbohydrate is starch. Ne? What is the product form now? When the function of amylase is over, what is the product form? Any volunteers? Suhana? Rohini? Maltose. Very good. Yeah. So the answer will be what? Name the reagent. Now they don't ask maltose. They ask name the reagent that can be used to when the function of name the reagent. Name the reagent, one question. Then write down the color change. There are two questions in it. To identify this product, what is this is the final one. So the starch has become maltose. To identify this, what is used? What is the, who can give me the answer for the part B? What is used to identify this? Any volunteers? What is used to identify maltose? When the starch is completely converted into maltose, what is the reagent used to identify? Part B, any volunteers? The answer? And you need to give the color change also. Yes, Sohana?
Benedict solution.
Very good, Benedict solution. Yes, very good, Sohana. And what is the color change? Can anyone else, or either Sohana or anyone else can give the color change also with this? What is the color change when you add Benedict solution into maltose and heat? Benedict test, what is the color change? Initial and the final color only. What about the other students? Only Sohana raise the hand. Rohini? Anyone else?
Blue, green, yellow, orange, and brick red precipitate.
Yeah. Finally you get brick red, but no need to write all the color change. I mean the series of color change. You can write the initial color and the final color even enough. So first write name the reagent. Answer will be Benedict solution. Name the reagent, Benedict solution. Or Benedict reagent. And that is number one. Then second you have to write the color change. Blue to brick red. If you only can write all the colors, no problem. Blue to brick red at least. If there's color changes, then you have to write all this. Blue turn into brick red color. So what are the two answers here? Reagent to identify maltose Benedict solution or Benedict reagent, and the color change blue to brick red. Right. Please raise the hand those who got part 5 A and B correct. Right. How many of you got this? At least one of these correct, at least. How many of you? Right, very good. Himavi. Okay, very good. Okay, some of you have done it well. Very good. Remember, this is O-level exam type question. This question, please put 3 stars. Upcoming O-level papers, even they can ask this. Right. Then question number 3. That is the end of question number 2. I'll erase the screen. Last question, question number 3. Last question number 3. Look at the screen. Part 1A, any volunteers? The specific properties. You learn 4 specific properties of water. Specific properties of water. Coolant property, solvent property, right? Cohesive and adhesive forces. Yes, I'll ask the answer from Bhatika.
The first one as the solvent.
Solvent property, yes. Good solvent, very good. Good solvent or solvent property, yes, correct. As a good solvent or solvent property. What are the specific properties? So you write a solvent property. Solvent property. Or you can write good solvent, right? The next one. When water turns into ice, it floats on water. That is what? What is that called? What is that? There are 4 specific properties of water. I'll ask the answer from Bhatika. What about the other student? No.
It's a differential expansion in freezing.
Very good. Answer is correct. Differential expansion on freezing. Differential expansion on freezing. That means what? When water turns ice, the volume increase. It's called differential expansion on freezing. When water turns ice, when water freeze and become ice, it occupies more volume. It takes more space, more room, right? That's why you should never fill a glass, or say, imagine, I'll give one example here. If you completely fill a glass bottle with water and put this in the freezer, you tightly close the lid and put this in the freezer, what will happen? What will happen? If you completely fill this entire glass bottle with water and put this in the freezer, what will happen? No space to expand. You have tightly closed. The lid is tightly closed. When the lid is tightly closed, no space to expand, this will blast. Then you can collect the pieces of glasses inside the freezer. So therefore, you should never put the glass bottle completely filled with any drink or water in the freezer and keep it the lid closed. I'll give one more example. You can do this as a practical, as a small, because anyone has a refrigerator in the house. You can take a glass and put a rubber band around this glass in somewhere in the middle, right? Up to that rubber band mark, you fill water. You fill water. Up to the rubber band mark, you fill water. After that, you put this in the freezer, keeping this glass upright. Keeping this glass upright. You can check whether the level, when it turns into ice, whether the level has gone up or down. Definitely the level will increase. So this is only water. When it turns ice, the level goes up. So then you get ice here, but it occupies more space. So even if you take this something called beam packet, like you get the inside the polythene, small bag, like you get ice, like what is this called? They put some coloring agents, sweetness and everything, and you get like ice cream like thing or yogurt, whatever. So then when it melt, it takes less space. When ice melt, it takes less space. When water turns ice, it occupy more space. It occupies more space. Therefore, we call it. That's why when volume increase, what density equal mass over volume. Density equal mass over volume. When water turns ice, what happened? If you're going to copy down this in a short notebook, when water turns ice, volume increase. When water turns ice, look at here, I'll highlight. Ice, more volume than water. Therefore, when the volume increase, density decreases. So therefore, ice has low density. Look at here. You can mark this, very interesting. Ice, low density. Relatively density is lower, but water has high density. So ice and water both made of H2O, but density different. The same gram. Imagine here you get 50, say here 50 grams, water also 50 gram, ice also 50 gram, mass same, here the mass constant, mass 50 gram both, but volume different. Ice more volume, the same mass than water. So therefore density will be different. So when the volume goes up, when the volume increase, density decrease. So here low density, water low density. Sorry, other way around. Water has high density. Ice has low density. Why low density? High volume. So above ice you can write low density. Relatively density is lower than same mass of water. So this one has high density. Therefore, who is going to float? Ice floats on water. Ice floats, or ice will never sink in water because of this density decreases when volume increase. So this explanation is important. Otherwise, you just memorize differential expansion or freezing. That's it. You don't know what is happening. Differential expansion of expansion and freezing. FR-EE-Z-I-N-G. Now you can understand why ice floats on water. Both ice and water made of same substance, H2O water molecules, but when it turns ice, like actually you can get the detailed explanation from chemistry. The answer is there in chemistry. Right. Differential expansion and freezing. Right. Next one. Water is transported upwards through the trunk of tall trees without any break. The water column continuous. Who can give me the answer for the part C? Part C, anyone can give me the answer?
Adhesive.
High cohesive and adhesive force.
Very good. Very good. High cohesive and adhesive forces. High cohesive and adhesive forces. Okay. Anyway, now this is unit wise. Each theory unit, at the end of the theory tute, I have given some practice questions. But remember, after March, right? Most probably after March, I'm going to start the paper class for your grade. For your batch also, I'll be starting a separate paper class. Then we'll be discussing all the past paper questions, model paper, support seminar paper questions from this lesson. But you need, before you go to next lesson, you should know, you have to practice few questions. Otherwise, you don't know what type of questions you are getting in the paper from this lesson, right? So the answer will be high cohesive and adhesive forces. 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 Otherwise, the water column break. Water molecules are attracted to each other because of cohesive forces. High cohesive water molecule attraction. Water molecule and the stem, the xylem, or those tubes attraction adhesive. Okay, so both help to climb water without any break, without any gap upwards. Right. Part 2, who can give me? Basic unit. Underline the keyword here, basic unit. Basic unit of whom? Carbohydrate. And basic unit of DNA. Who can give me the answer for the 2A? Any volunteers? Any volunteers? 2A the answer. What is the basic unit of carbohydrate? What is the basic unit of DNA? Sohana? Vatika?
Carbon.
Very good. Carbohydrate, the basic unit glucose. So actually carbohydrate are many types. So actually you should better write here the actually monosaccharide, or else you can write here there are carbohydrate basic unit monosaccharide, or if you write glucose also can be accepted. Right. Why? The starch made of glucose, cellulose made of glucose, glycogen made of glucose. All the carbohydrate contain glucose, even monosaccharides and disaccharides except fructose, galactose, others. So therefore better write monosaccharide, but I think this question they should have given starch here, right? DNA, what is the basic unit? What is the basic unit of DNA? Any volunteers? Sohana?
Nucleotides.
Very good. Nucleotide. Very good, Sohana. Nucleotide. Deoxyribonucleotide, DNA. Ribonucleotide, RNA. Yes. Nucleotide will be the basic unit of DNA or the building blocks. Number 3. What is the carbohydrate important for the formation of cell wall? Cell wall is made of which carbohydrate? Cell wall is made of which carbohydrate? Carbohydrate that important for the formation of cell wall. Cell wall is made of which carbohydrate? Yes. Vatika? Suhana?
Cellulose.
Tisavi?
Cellulose.
Yeah. Rohini? Sandesh?
Cellulose.
Very good. Cellulose. Very good. Cellulose. All of you are correct. Cellulose will be the uh, carbohydrate which form the cell wall. Last one, common molecular formula of carbohydrate. Yes, it's there in the textbook also. Common molecular formula of carbohydrate. Who can give me the common molecular formula of carbohydrate? You should know the general formula of even glucose, glucose. That means monosaccharides and disaccharides also. You should know the common formula. Yes, who can give me the answer? I'll ask the answer from Sachin, Sandusha.
CXH2OY.
Yes, very good. CXH2OY. I have given this in the theory too as well as it's there in the textbook also. CXH2Y, but when you put here Y, we have to put brackets for water because Y belongs to both hydrogen and oxygen. X and Y can take different numbers, right? So it's like if you take glucose, X equals 6. For glucose, what is X here? 6. X equals 6 for glucose. And Y will be again 6. Then you get what? C6 H12O6 like that. So when you get this, the final one. Right. So but here the answer should be CXH2OY. Answer will be C6H2OY. Shall I raise this question? That is the end of theory to the last question. Yeah, that is the end of this. Now we have to start the second lesson. Chapter 2. Okay, I'll erase the screen. Anyone still coming down? Right, done, right? Okay, then next one. Let's start the new lesson. Unit 2 Physics. Motion in a straight line. Grade 11, grade 10 second chapter. Here, motion in a straight line. So there are different type of motion. So all the motions are not in a straight line. Some motions what? Rotational, revolution, vibrational motion. Vibration, rotation. So example, the earth revolves, revolution. Earth revolves around the sun. Earth rotates around its own axis. Rotation, revolution, then vibration, vibrational motion. So when the fan rotates, rotation of the fan, wheel rotates. But here we are not going to discuss those types. Okay, so like this periodic motion, like Orosio Batta, pendulum of wall clock, moving left and right. So that is the ancient times we use clock tower and all this pendulum, or we call it Orosio Batta. So there are different type of motion. But here it's limited only to motion in a straight line. That means what? a vehicle is going on the road, or you are running 100 meters race. That is what? Oh, a coconut falling from a tree. So that is straight line. When coconut falling down, straight line. Or else you're driving a vehicle. Okay. That means maybe the road not straight, but you are not coming backward. So forward and backward, or you are not going like in a carnival or something. We call it Marakali or something. That is not linear, right? So this circular motion there, yeah, various type of motion. Gas molecules now around you, there are so many gases, they are not at rest. Gas molecules, you exhale carbon dioxide, they are moving. Or sometimes gas molecules can vibrate. You are inhaling oxygen, gas molecules are moving in there. So when we talk the motion in a straight line, there are two physical quantities called displacement and distance. So that's what you get. Before that, now you can see, look at the textbook also, they have given a diagram. If someone is going from A to B, what is the shortest path? I'll highlight here. The shortest path will be what? 160 meters from east to from west to east. So this side is west, I say this side is east. There's a definite direction, and there's a definite direction, and the distance travel 160. This is called, if you only can mark with a pencil, those who have got the printout, the textbook, this is called what? Displacement. What is this called? This is called displacement. Look at the screen. What is called displacement? This is called displacement. Displacement. All the others, so that means the straight line, right? The shortest distance. So this is the shortest distance between A and B. So I'll write here the shortest distance, shortest path. That is the shortest path. But all the other, like so R, Q, all the others, what? Path P and path Q and path R, what? They all what? The direction changes. So it's going towards the north and again towards east and again towards south. Direction changes with time. Now it's towards south. So direction changes with time, up and down and left and right. So this no definite direction. Even path Q no definite direction. It towards north and again towards south, like that. Path R also no definite direction. So all these P, Q, R, that is called what? Distance. Now do you understand the difference between the distance and the displacement? Distance means the shortest, displacement means the shortest distance between any two points. Distance will be the total length of path. I'll encircle this to this, very important. Distance here 160 meters. All the others more than 160. When you are driving a vehicle, or if you are going in a vehicle from Colombo to Kandy, or Goal to Madra, or Colombo to Goal, so it's not a straight line. Direction changes because all the roads are not, even the highway, like it's not 100% straight, like the direction changes. Therefore, if there's no definite direction, and if it is the total length of path between 2 points, we call it distance. Therefore, P, Q, R, all these are distance. Distance. This also distance. This also distance. Distance. But the middle one, you can see the dotted line here, that is from west to east, and that is the shortest distance between these 2 points, 160 meters. All this 320, 200 and 240, greater than that the length. So do you understand the difference between what? Distance and displacement now? Distance, the direction changes from time to time, but distance, displacement, direction fixed, constant. It won't change. So distance, direction changes. Displacement, direction does not change. It's the same direction, west to east. Okay, so that is the difference between distance and, so if there's a definite direction, shortest path, direction definite, has a direction, but distance no definite direction. Direction changes because you turn the vehicle left and right. No definite direction. No definite direction. No definite direction. no definite direction. Here has a definite direction. Therefore, if there's a definite direction as well as a value, we call them vectors. Well, such quantity is called, there are not only displacement, there are many vectors, but the name given to this such measurements are called vectors. And this one is known as scalar. What? The distance is known as scalar. Again, I'll repeat. Both these having a value. Displacement, look at, they have given in the diagram 160 meters. Displacement. Distance, they depend on the path PQR, it takes different values, but it's higher than the the shortest path. So therefore, the scalar quantity is no definite direction, only the magnitude, only the value. What is common to both these vectors and scalars? It has a value, a numerical value. But out of these two, which one has a definite direction? Only the displacement. Distance, not definite direction. So that is the difference between displacement and distance. I'll give one more example. A batsman is running between two wickets. Is that displacement or distance? Exactly between those two wickets. So he's moving forward and backward net. Or if there's no barrier or disturbance from the ball or anyone else, so they are going straight, right? That is it will take less time. If they are walking in different paths running, then it will take more time and then they will get run out. Or when a coconut is falling from a tree, that is also displacement, unless there's no barrier in between the ground and the tree. So that is also displacement. A coconut falling from a tree, like that. You need more examples for this to understand this. Very important. So this is what so this is unit 2 at the beginning. Right? Now what is the meaning of vector? Vector and scalar. Not only these two, displacement and distance. There are many vectors and scalars. Okay, let's see now back to the theory dude. So now they have given the next page of textbook, page number 2. Now remember, please raise the hand those who have not got the printout, the textbook yet from the school. Please raise the hand those who have not got the textbook yet from the school. Grade 10 textbook. Grade 10 textbook, those who have not got from the school. From the school, grade 10 textbook, you didn't get it. Please raise the hand. Part 1, there are two parts, part 1 and part 2. Only for all the others got grade 10 textbook. Good, very good. So those who have not got the textbook from the grade 10, I forwarded to your WhatsApp the PDF version of the second chapter. Then you can refer that. Look at page number 2 top. They have given here. Only magnitude. Only underline magnitude, and that means no direction. No direction here, no definite direction. Page number, what is this page? Page number 24, no? Page number 24 in your textbook. Page number 24 in your textbook. No definite direction. No definite direction. Only the magnitude, only the value. Distance you can tell 300 or 1 kilometer. No definite direction. No definite direction. That's why we call it a scalar quantity. But if there's a magnitude, I highlight the word here. If you want, you can underline with the pencil at least. Magnitude and direction both there. Both magnitude and direction there, that is called vector. When both magnitude and direction is there, that is called a vector. That is called a vector. If only magnitude, scalar quantity. So what is the example here? Distance here. We discussed distance, no definite direction. Therefore, that comes under scalar quantity. And here I give the displacement. Displacement, you can say it is under vector. Why? Displacement, direction is definite. But distance, it's not definite. Right? So that is not our fault, but that is the nature, right? That is why we call it a distance. In Sinhala, we call it Vistapanya saha dura. Distance dura, displacement is Vistapanya. So what are the examples for displacement? A batsman running between wickets, falling a nut or a fruit from the tree straight vertically down, and in addition that you can write between two trees a bird is flying straight between two trees. So that is displacement. But if a vehicle going from Colombo to Kandy, a vehicle going between traveling between two cities, that is distance. That is distance. When you're going from your house to the school, that is distance. When you're going coming back from your school to the house, that is also distance, not displacement. Not displacement. Unless you have a helicopter or something, you can go in air, so straight in a straight line, but that also there can be sometimes barriers. Right. Okay, did you all understand? Now I explain in detail what are scalars, what the scalar means what? Only the value. Value means the only the magnitude. Magnitude means the value. So 200 or 300 or whatever. Example, right? Say 100 meters. That is the value. Value is 100 here. 100 meters distance. That is scale. Why? Only magnitude. Only magnitude highlight. Here what happened? Both magnitude and direction both there. Then we call it a vector. Then we call it a vector. So it's not hard, very easy. Why magnitude? Value. Both has value. So this one will be less than that display. So it may be say 70 meters. Because distance will be always greater than the displacement between any 2 points. Now let's move back to the theoretic and come to the blanks for the so other examples also there are the speed and mass, time, all this scalar, but anyway we are going to discuss that in detail in the theoretic. Okay, I'll erase the screen now. Let's move back to this. Right. So complete the blank now. Physical quantities with a particular direction as well as magnitude. Direction highlight, magnitude highlight. Direction and magnitude. What is called? They are called both with both direction and magnitude. They are called vectors. Vectors. Please complete the first blank. Please raise the hand those who have got the printout of this. I think I forwarded this yesterday, right? Or day before yesterday. Vector. No, last week. No, yeah, it's 1 week back. Last week I posted this to your WhatsApp. Please raise the hand those who have got the hard copy of this tute. How many of you got the hard copy of this? Those who have got the hard copy now, then you can complete the blanks on the tute itself. If you have not got the printout of the hard copy yet from this PDF, please write only the answers and put the page number and the number 1, write the answer already, right? Okay, very good. Those who got the printout. Very good, you are well prepared. Okay, very good. There are nearly 15 students, right? Second blank, right? Only magnitude but no definite direction. If you can write here quantities with only magnitude, if you can add the word here only magnitude but no direction, without direction. Only magnitude, no direction. Look at the screen. Only magnitude and without direction. Only magnitude but no direction. They are called scalar quantities or non-vectors. Remember, physics little harder than biology, okay? Because physics you have equations, physics you have calculation, and physics you have units, and physics you need to remember the equation, units, calculation, understanding, memorizing, all there. So I have given examples for this vectors. I have given a few examples. So displacement, there's a definite direction. They can ask these examples with important. Remember, because I am not going to explain all this one by one, because in this lesson itself we are going to discuss all this. Don't worry, acceleration, deceleration, velocity, we are going to discuss all this. But anyway, you have to put a star here because they can ask all paper MCQs. Which of the following is not a vector? Which of the following is a scalar quantity? Like that, they can ask MCQs from this. That's why. Right. Then next one. Number 2. Okay. Can you all please write in this diagram? Look at the screen, everyone. This diagram below 100 meters, right? What is that? Distance or displacement? 100 meters. So you can put the arrow like this way. So direction is definite. So this side, if I take west, this side it will be east. Right. So it's going from west to east. But this one not happen. It's the other diagram from A to B. That also reaching the same point, but it is not definite. So it's towards north and towards south and towards east, like that. No definite direction. Therefore, this 180 meters we call it distance. Both are reaching to the same place, but 180 meters called what? 180 meters known as distance. And 100 meters known as displacement. Displacement. Is that clear? Any more questions? Please highlight distance and displacement. If you are going to use two different colors for this. In the diagram also you better mark that. And I'll use a different color for this. I'll use this one. 100 meters will be the displacement. 180 will be the distance. Next one. Number 2. So I have given a difference between distance and displacement. First one, distance is the total length of path between 2 points irrespective of its direction. Total length of path between 2 points called what? Distance. Example, right? A vehicle traveling from between two cities. A vehicle traveling between two cities. When a vehicle is traveling between two cities, what is? Definitely distance. You can't tell displacement because vehicle sometimes it will turn that side, this side, direction change. A vehicle traveling between two cities, between 2 points, so between two cities, they are familiar between two cities, between from Colombo, a vehicle traveling from Colombo to Kanti, simple. A student traveling from the school to the house. If the house is next to the school, you can make it displacement, right? But most of the students, the house is far away from the school, no? Then it's distance. You can write example for the next one. I'll erase this. Shall I erase this? Anyone still copying down? Please raise the hand. Those who are still copying down, please raise the hand. Done, right? Shall I erase this? Did you all label the diagram? 180 will be distance in the diagram and 101 label as the displacement. Then it's easy to understand. Which one, Sachin, when you're done, please lower your hand. Right. Then I'll move on. Part B. So if you take part B now, distance and speed interconnected. So if you know the time and the distance, you can find the speed. So if you divide the distance by time, that is called the speed. You had done this in, I think, grade 6 and 8 also. Distance divided by time will be the speed. So distance measured in meters, time measured in seconds. Therefore you get here the speed equal distance divided by time. If you want to get distance measured in meters, time measured in seconds, SI unit of the speed, right? Meters per second. MS minus 1 meters per second. Then the mean speed will be what? This is the most important thing. This definition please highlight. They can ask that in the exam. Sometimes they might ask calculate they don't ask you to calculate the speed. They'll ask calculate the rate of the change of distance. Or else they can ask distance traveled in a unit time. Calculate the distance traveled in a unit time. Or calculate the rate of the change of distance. Then the same equation you had to use. Sometimes they will not mention the word speed in the exam. They will ask you to calculate the rate of the change of the position. How fast it's moving. The speed means how fast it is moving. Higher the speed, higher the that it's moving fast. So, but the problem is this. Imagine now a vehicle is traveling. Okay, I'll give one example. From somewhere from Kotta to Gol, we assume 100 kilometers. This is one of the best example. What is the difference between the speed and the mean speed? Look at the screen, everyone. If you take a vehicle going from, say, in highway, going from Kotta to Gol. Now, is that mean the vehicle is going to the same speed forever? I mean, throughout its journey. It will apply brakes. When the accelerate, it will slow down. Therefore, it's not fair to get the total distance and find the speed. Total distance d. So it's more. And when it reached the destination, you can get the total length of path. It can be like straight line, like direction can be changed, but if you take like this, it's like displacement. So but anyway, it changes now. When the scalar light, it will slow down. So and when someone is going to cross the road, or it will slow down, or driver might apply brake. So therefore, throughout the journey, it's not the same direction. Therefore, then we have to calculate. So imagine here 300 kilometers, and you travel this within 30 hours. Or I'll take here within okay. So 30 hours. Assume 30 hours taken. What is the speed? 100 kilometers divided by 30 hours. The speed will be what? 300 kilometers divided by 30 hours. What is in it? 0, 0, cancel. 3, 3, cancel. And what is left? 1. Only 300 times 10 kilometers per hour. But you get the answer 10 kilometers per hour. That is correct. 300 divided by 30. But actually, it doesn't mean throughout the journey it's going to the same speed. 300 kilometers divided by 3 hours. Then you get the answer 300 divided by 3 hours. Kilometers divided by 3 hours. So then you get the answer 100 kilometers per hour. H minus 1. But it doesn't mean the vehicle is going to the same speed forever until it's reached the destination. It might slow down. That's why we need to calculate the mean speed. Otherwise, we can use just the speed here. Mean speed means what? Total distance divided by the total time. Total distance travel divided by the total time. Right. That's how you get it. Why mean speed? Mean speed you get. Now what is actually the idea, the calculation here is that that is actually the mean speed. The 300 kilometers in 3 hours. It does. Then you get the answer 10 kilometers per hour. But it doesn't mean throughout the journey it's going to the same speed unless they mention constant or uniform speed. That's why we need to calculate the mean speed or average speed. You can write within bracket average. Within bracket you can write mean speed is also known as average speed. So what is the SI unit of the average of the mean speed? Meters per second. Meters divided by second. So they can ask this for the MCQs. Units of measuring the speed. Okay, then next one. So what is speed? Rate at which the distance is changing, or else how fast you are moving, in other words. Then next part. SI unit important. SI unit important. I'll erase the screen. Look at this. Part 2. Displacement. Now displacement. Displacement is the shortest distance between shortest distance in a particular direction. If you can add shortest distance between 2 points in a definite direction, that also should be there in definite direction. In a definite direction. In a definite direction. So you can write the examples for this one. Not falling from a tree. A fruit falling from a tree without anyone's without any other external influence. A fruit falling down from a tree. Then what else? A batsman completing 2 runs fast. A batsman completing a run fast. A batsman completing a run fast. 1 or 2 runs in a straight line they are running. So those are the examples for the displacement. Now I have given small calculation here. Now out of AB plus CD will be what? Now someone is wanting to reach from A to B. If someone is wanting to reach from A to B, what is the shortest path? Directly you can go from A to C, right? But if someone travel first from A to B and then first from A to B and then from B to C, that's what they have given here. What is the total called? 40 meters plus 30 meters. What is the total? Who can give me the answer for this? What is the total distance travel? In this diagram, write everyone. Total distance travel will be how many meters? See, right, the leftmost side here, rightmost side. Distance travel will be how many meters? Any volunteers? Savidya? Rohini?
70 meters.
7 meters.
Very good. So distance equal, please write 70 meters. Distance equal 70 meters. So please write somewhere, depend on this space. Distance will be 70 meters. Distance equal 40 plus 30. Then you get the answer. What is that? 70 meters, ne? 70 meters. So final answer, you have to leave units. That is the total length of path. Now, what the red one? So this one, right, about this one, that is the shortest path. If someone can reach from A to C through this path also, that is called displacement. That is called displacement, A to B. Now look at the screen. A to B displacement through X. X will be displacement. Shortest path, ne? So this one above this, right, displacement. Now how can we calculate this displacement? How to calculate displacement? Yes. How to calculate the displacement, because they are not given the value. Can anyone suggest a method to calculate the displacement? I want to find the shortest distance from A to C. In other words, I want to find the displacement. Who can suggest a method to find the displacement? Please raise the hand. Only 3 students raise the hand now. Yes? Only 4 students raise the hand. You have done basic maths. I want you to copy down this diagram in your writing book and find the displacement here. Please write your distance. Okay, part 1 I'll write part 1 distance equal, okay, this much of meters, 70 meters. Please write it. Distance equal 70 meters. Now I am going to write displacement. How to find? X squared equal, X will be the displacement. X squared equal what? Okay, I'll ask the answer from you all. Malitma, Sandusha, Shane.
Pythagoras theorem.
Very good. Pythagoras theorem. What is Pythagoras? X squared equal 40 squared plus 30 squared. Then X squared equal what? 40 into 40,000 600 plus 30 squared will be what? 900. 30 squared is 900. 30 into 30 900. 40 into 40,600. Then what is the total? 2,500 meters equal X squared. So what is the value of X? X equal the square root of this 2,500. What is the square root of 2,500? Who can give me the final answer? X equal how many meters now? Any volunteers? Because the display from A to C, A to B, and then from B to C, it takes 70 meters. So if you are directly moving through the displacement, that X path X directly from A to C, it will take, definitely you should get the answer the less than 70 meters. Less than 70 meters. So run the calculation and let me know the answer for the X. Yes, any volunteers? Maritma, Sandusha?
50 meters.
50 meters.
Huh?
50 meters.
Yeah, all of you get the same answer. Very good example. 50 into 50 will be what? 2500. So answer will be 50 meters. This also very important. You better copy down. If you have no space in the tute to work out, in the tute you can mark this displacement A to C, and then the other one, this 40 plus 30 together known as distance. And you draw this diagram and write the Pythagoras theorem and apply the lesson, get the answer. So when you're done, please lower, those who are still writing, please raise the hand, otherwise please lower your hand. If I still writing only, please keep the hand raised. Once you finish, please lower your hand. Then I know all the students have finished writing this. This is very important. Put a star near this diagram. So Hanan Sassarin, when you're done, please let me know. Lower your hand. I'll still writing. Now most of the students, they find difficult at the end the chemistry and physics when the exam is closed. Now you might not believe this time you don't get the diagnostic test or the Western Prize diagnostic test. So I heard many teachers complain grade 10 part they have not done properly. You get oral paper not less than 40, definitely more than 40% from the grade 10 work in the oral science paper. You can understand the importance of the grade 10 syllabus for your oral paper. Nearly 50% sometimes you are getting only from grade 10. Therefore, by studying only the grade 11 work, you can't go for A pass. Grade 10 also equally important. Right? But most of the students, they are not aware of this. Right, then I'll erase the screen. All of you are done. Right, done. The next one, displacement is the shortest between 2 points. I told you an example. You can write one example: nut falling from a tree, or batsman running between wickets. A batsman running between wickets very fast. Right. So if you divide, now earlier I told distance over time will be the speed. Distance over time the equal speed, we discussed that before. Now velocity. Instead of speed is velocity. Why velocity? Because it has a direction. Because velocity you calculate by displacement divided by what? Divided by time. Displacement divided by time. That is called the velocity. Look at the screen. This velocity is the rate of the change of displacement. Please highlight that. If they ask to calculate the rate of the change of displacement, they are asking about the velocity. So what is the definition of velocity? Rate of the change of displacement. How fast the position change. So you are not staying at the same place forever. Now also, are you all at rest or moving? Are you all at rest or moving now? Those who are moving, please raise the hand now. Those who are moving now, please raise the hand. Those who are staying at rest, please raise the hand. No, all of us are moving. You are staying at rest. Why? Earth is revolving and Earth is rotating around its own axis. Right? So you don't see, but because entire you are with not only you, the things around you also with, like if you imagine you are going inside a vehicle or in a bus, you see the same set of people around you. I'm saying same bus. Why? Because when you are not moving alone, you are moving with the other people in the bus. Same scenario when you are on the earth, not only you, the rest of the things around you also moving with you on the earth when the earth is revolving and rotating around its own axis. Therefore, anything, even non-living things are moving now. Not only living things. Right? They are not moving alone. They are moving because earth is revolving. Earth is rotating. I hope you understood what I am saying. So that's deep understanding about the motion. So all are in motion. Are the gas molecules around you now at rest? No, they are moving. You exhale carbon dioxide molecules are moving away from your nose. And oxygen molecules are moving towards your nose. Gas molecules moving. But they may not move in a straight line. Okay. Then you're moving, right? So you might not believe. Actually, Earth I don't have time to explain. You can search in the internet how fast Earth revolve around the sun. It's so fast, faster than any other vehicle in this world. So if you take a football, if you take a large football or barrel and put a small ant on the football and move this football slowly towards left or right side, or clockwise or anti-clockwise, the ant won't feel that, and ant will think I am at the same place. The football, the same color will be observed, or the same pattern will be observed by that animal on the football, but actually that animal is moving with the football. So that's so, therefore nothing. Not only that, I think in the next lesson chemistry you will learn about electrons. I think you have learned electrons. Are electrons at rest? Your body content full of electrons, protons, neutrons, or elements, atoms. Are they at rest? No, electrons are moving around the nucleus, like just like planets are revolving around the sun. Therefore, all of you have electrons. All of us have, we are made of atoms. Atoms consist of electrons, protons, and neutrons. So this level of understanding is very, very important. Right? Okay. Now, same as when you can never tell a vehicle going with the same speed forever. From time to time, when there's a color light, it has to slow down and stop. Therefore, it will travel maybe 100 kilometers, and you can give one answer, but it doesn't reflect each second at each point. It's moving at the same speed. It doesn't. That's why we use average velocity or the mean velocity. That is total displacement divided by time taken. Total displacement divided by time taken. Total displacement divided by time taken. Total time. But actually it doesn't reflect each second the velocity, because velocity changes. Let's say mean velocity is used rather than instant velocity, right? So what is it called? Total time taken. Total displacement over total time. That is called the mean velocity or average velocity. Right. Then what is the SI unit of velocity? If you only write within bracket in front of displacement, write meters, and in front of time write seconds. Then SI unit of velocity write ms minus 1 or meters per second. ms minus 1 or meters per second. So then how to calculate the displacement? Displacement equal what? Average velocity or mean velocity into time. You can take time into this side. Here, look at this. Displacement equal mean velocity into time. Into time. If you can write here mean velocity, you can calculate by, you can get the mean velocity if you want. Take the initial velocity and the final velocity and add and divide by 2. That way also you can get it. You can rearrange the equation. Take time, total time into the other side and multiply. Look at here. It should be total time, total time taken. You multiply with mean velocity and you get the displacement. This is total time taken. Right. Then, okay, now what are the things we discussed now? I told you, okay, look at the screen again. If I quickly summarize, this lesson is little harder than the other lessons. So first I told distance. Then from distance you can get the speed. How? Distance divided by time. Then number 2, displacement. From displacement you can get what? Velocity. So I told distance, no definite direction. When a vehicle is going from Colombo to Kandy, its distance, direction of the vehicle changes, so its motion changes, direction of motion changes from time to time. Therefore, it is a scalar. And this also, therefore, the speed also you get from the distance over time. Therefore, it's scalar. That means no direction. Displacement is a vector. Therefore, velocity also vector. How to find velocity? Velocity equal displacement divided by time. And you should know the equation for both, and both measured in meters per second. Both is measured in meters per second, SI unit. If you can tell this in kilometers per hour or centimeters per second or any other unit, but SI unit will be meters per second, both these. ms minus 1. Simple M. I'm just summarizing the first page what we discussed up to now. So the distance measured in meters, time measured in second, time measured in seconds. So sometimes in the exam they will give time in minutes, so you have to convert that into seconds. Meters, this also meters, right? Okay, if you want to copy down this in your short notebook, distance scalar, the speed also scalar quantity, displacement vector, and velocity also vector. It should be vector, VECTOR, sorry. It's vector. Right. You can add this to your short notebook. And what are the other one? Then you get for the mean speed also the same unit. If they ask you to calculate the mean speed, you get the total. Actually, you cannot calculate the exact speed from time to time. It's not practical. It's the speed of the vehicle and slow down, stop from at the color light, again speed up and again stop, right? Throughout the journey it's not going with the same speed. That's why we need to calculate the mean speed. Practically its mean speed is more practical than calculating the exact speed from time to time. Then here also actually we calculate the average or the mean velocity rather than exact velocity from time to time. So therefore we cannot calculate the exact speed or velocity. It's very difficult. Therefore we get the mean velocity, right? Sometimes what happened, okay, I'll give one very interesting one instance where they calculate the exact speed at that moment. High speed, the police, they catch you, they will have some device to detect the speed of the vehicle. They are the instance, you are going with 150 kilometers per hour in the highway now. Maximum the speed limit 100 kilometers per hour, now it's 150. You have to appear in the court and pay you have to pay fine, the dagana. But sometimes what happens, if there are no police officers, then if you go with the 150 kilometers per hour, 120 kilometers per hour in the highway, and you in the middle you take a break. So you go to the that area, parking or whatever. There's some areas where you can use the you rest a bit, half an hour. Then at the destination, when you pay the bill, the ticket, they will not notice that you have come very fast because you are resting somewhere in the middle. Then it will take more time. Therefore otherwise what happened, at the destination they'll think at 100 kilometers per hour at least it takes nearly 1 hour, but you have come here within 30 minutes from Kottawa to Goal. Then they will catch you. How can you come within 30 minutes? Because if you drive maximum speed 100 kilometers per hour, within 1 hour you can travel 100 kilometers. Therefore now you have come within 30. Then also you get caught, right? They don't need to catch you in the middle. They can catch you at the end if you are not stopping at all and if you are going to the same speed forever. So this practical application also very important, right? Very important. Therefore it's very difficult to record each instance the speed. Therefore we go for the average speed. Each instance we can calculate the velocity, we cannot, difficult to express. Therefore we go for the mean velocity. Is that clear? Right. Now you know what is the benefit of using the mean velocity or the average velocity. It's easy to express than the exact speed from time to time, right? Then number 3, acceleration. What is acceleration? How fast the velocity is increasing. If velocity increasing rapidly, some drivers are flying, not driving. From 0 to within 2 seconds, speed up from within 10 seconds. Within 10 seconds, the speed of the vehicle from 0 to 100 kilometers per hour. 0 to 100 kilometers per hour. That means what? They are flying. That is called high acceleration. There's in a motorcycle even there's an accelerator. You have to turn that, or you are using the hand, or in a car there's an accelerator. There's a separate pedal for the accelerator. When you press this, the vehicle is going fast, and the other one is the clutch and the brake pedal. There are 3 some vehicles, so that is auto, like what is it called, fully auto, right? Fully auto, that means no clutch here, right? Only the brake and the accelerator, But usually the lorry bus, there's a, I think, clutch and the brake and the accelerator. There are three. Number one, the clutch. Number two, the brake, and number three will be the accelerator. So when you accelerate the vehicle, the velocity is rapidly, you have the speed is the velocity is increasing. But if it is uniform velocity, that means no acceleration. The velocity no change. Acceleration means increasing of the velocity. What is acceleration? Increasing of the velocity. Opposite of this, deceleration, decreasing of the velocity. If there is no change in the velocity, that means no acceleration. But again, I'll repeat. Then what are the three things? Okay, right here, I'll use this white background. Okay, you can write here velocity increase, velocity decrease, velocity no change. Okay, sorry. You can copy this in a short notebook. Okay, if I write here velocity, there are three things. Velocity, one is what? Velocity increasing. Velocity increases from 0 to increasing of the velocity. The other one is decreasing of the velocity. Velocity decreases. You apply brake, decreasing. And the third one, velocity constant or uniform. Constant, or we can write uniform. These are the three things. Any vehicle, anything that is moving should come under one of these. No, definitely. You can't think about a motion without this. Either velocity increase, either velocity decrease, or either velocity constant, or we call it uniform. Anything vehicle or anything else in the world, when it is moving, it should come under one of this. Velocity uniform or velocity constant. If velocity is increasing, we call it what? Acceleration. What is called? Acceleration. Please copy down this. This is not given in your textbook. This is short method, short note. Velocity increasing means what? Acceleration. Velocity increase means it's accelerating. Acceleration. Then velocity decreasing means deceleration. Decreasing of velocity means what? Deceleration. Velocity decreasing means deceleration. Opposite of acceleration. Deceleration. Sometimes we call it retardation. Retardation. And velocity constant means what? Zero acceleration, no acceleration. No acceleration means zero acceleration. No acceleration or deceleration. No acceleration or deceleration. No acceleration or deceleration. That means zero acceleration. No acceleration or deceleration. That means it's going to the same speed. That means what? We call it acceleration equals zero. Acceleration is zero. Now look at the screen. I'll make a small sketch of this graph also. Look at the screen, everyone. We got it like zero. That means no change. Acceleration I put here a equals zero. Zero means acceleration. A for acceleration. Huh? Right. No acceleration or no deceleration. If I represent this using a graph graphically, look at the screen now. Acceleration means velocity increasing of velocity. Look at the screen. When you accelerate the vehicle, passengers are moving backwards, right? Passengers are moving backward. So if you take a velocity here, velocity y-axis, time x-axis, what happened? With time, velocity increases. With time, velocity increases. Then this is how you can draw it. Velocity increases from 0 to say 100. That is, increases. It begins from 0, the vehicle start from 0, and y-axis velocity increase with time. If you are applying brakes, then velocity decreases and come to rest. Come to velocity becomes 0. Please copy down this summary. So everyone should maintain. Now today you have to open a new short note book, new CR book. That CR book, don't write anything else, only the physics short notes. You will not find those short notes in your textbook. That's why you don't get this diagram in your textbook. This is like, because when the lesson is hard, I'll use different methods teaching. Concept map, mind map, right? A flow diagram, different techniques, right, to make it easy, for easy reference, cross reference. When you are studying this before the exam, it will be useful, right? This type of note. Now here what happened? It decreases. Velocity y-axis, time x-axis. Now what happened? velocity you start from say 100, now it's become at the end 0. After say after about 10 seconds it becomes 0. Velocity is 100 to 50 and 60 and 50, and finally it becomes 0. It's decreasing. First one, acceleration. This is deceleration, that means negative acceleration. Then the other one is last one. These are the three types of motion any object in the world can experience should belong to one of these definitely. Anything that is moving should come under one of these definitely. The next one, if it is moving, if it is at rest, then you can't, there's no acceleration, there's no velocity. If it's something at rest, but that also you can't tell, that is relative to each other, but relative to the earth, like with the earth you are moving actually, like that's an advanced concept, right? The earth also revolving, we all are moving, your house and everything, right? And even at this moment. Last one, are you all copying down this in a short notebook, right? That means what? Acceleration, no change. Zero acceleration means what? Velocity constant, no change in the velocity. Constant means what? Velocity, no change. If you only can put an arrow always, constant velocity means what? No change of velocity. No change. It has a velocity. Velocity is not zero. It has a velocity, but it's not changing. No change of velocity. Velocity, no change. If velocity no change, we call it constant velocity or uniform velocity. Yeah, constant. If you write here velocity 10, after 1 second also is 10. After 2 seconds also is 10. After 3 seconds also is 10. So it's after 1 second, the value is, what is the value here? Look at here, x-axis time. After 1 second is, I put time here seconds, right? S within bracket seconds, velocity meters per second. You learn a unit. Here all these y-axis and x-axis you can write within bracket the time seconds. Here time seconds. After 1 second velocity 10. After 2 seconds also velocity 10. After 3 seconds also velocity 10. That means what? Velocity no change. After 4 seconds also velocity 10. Sorry. We call it constant velocity. Sorry. What is it called? Constant velocity. Velocity no change with time. Is that clear? Did you all finish copying down this? Velocity can increase, velocity can decrease, velocity can remain constant. So in all these three, what? It's moving, even though velocity is with the same speed is moving. That's why uniform velocity in a definite direction. Anyone still copying down this? Please raise them. Those who are still copying down this. Done, right? Shall I erase this? Right. Okay, then I'll erase this. Acceleration, deceleration, and zero acceleration. A equals 0 means zero acceleration, last one. So there are three things: increase in velocity, acceleration. This is the graphical representation. Decrease in velocity is deceleration. This is the graphical representation. Last one, no change in velocity, no change in the velocity or uniform velocity, that is zero acceleration. This is the graph. This is the graph. Very important. These are the three types of velocity time graph they could ask. What is this called? VT graph. The last one is called what graph? VT. VT means velocity time graph. These are called what graph? Because in this lesson you get a lot of questions from the graph, motion graph. We call them VT graph, V dash T. VT graph, velocity time graph. Sometimes you can see the run rate, how fast the runs are increasing. You can see the two teams cricket match, this team this way, the other team this way. By looking at the graph, you can tell who is going to win now. That means how fast the runs are increasing. That means what? The rate of increasing the runs. So then you can tell. So the falling of wickets also sometimes they mark here somewhere, like they put a dot here. So you can see the run rate. Run rate means what? The number of overs and the runs, right? The score. So it's easy to understand the graph rather than if you imagine what happened without this graph. If they put full text like a newspaper on the television screen, who is going to read that? It takes long time. But graph is very easy to understand. In your school office, sometimes the principal's office, they put what? Last year O-level results, 2019, 2020 O-level results, the bar graph, bar chart. So it's easy to understand what's whether the results has increased or decreased annually. Therefore, this lesson you get graph. You get questions from this velocity time graph. Okay. So I'll erase this now. Let's move back to the theoretic again. So what is acceleration? Acceleration means change of, please highlight this, rate of the change of velocity. What is the definition? Acceleration is rate of the change of velocity. That is also called change of velocity. These are like both these are accepted in the exam. If they ask what is known as velocity, you can write any of this. Rate of the change of velocity or change in velocity in a unit time. That means acceleration, please write here change in velocity. What is change in velocity divided by time taken? Change in velocity, look at the screen, change in velocity divided by time taken. So what is change in velocity? Final velocity minus initial velocity. Final velocity minus initial. Please write here final velocity minus initial velocity divided by time taken. Final velocity minus initial, I don't have to specify velocity. You write final velocity, velocity divided by minus initial velocity divided by time taken. How to find the change? Final velocity minus initial velocity. That is called the change in velocity. Change means final minus initial. Then final velocity we use V here. Initial velocity we use U. I have given the standard symbol V minus U. What is V final? What is U initial? Imagine final velocity 40, initial velocity 0. Then 0, 40 minus 0. The answer is 40. You start from rest. If a vehicle starting from rest, what happened? Initial velocity 0 and it gained 70 meters per second. Initial velocity 0, final velocity 70. It begins from rest. Time taken say 10 seconds. Then you can find the acceleration. If you know these three, you can find the acceleration. Initial 0, final velocity 70, time taken to increase the velocity up to, until 70 is 10 seconds. Then you know the time taken. This in the exam, you can use this symbol equation for the calculation. No need to memorize the word equation. You can write the word equation. Symbol equation, please put 3 stars. This expression, please put 3 stars. Very, very important. Every year, O-level paper, you get a calculation from this. Definitely. How to calculate acceleration? Final velocity minus initial velocity over time taken. Then you can see how fast the velocity is increasing. If you get here 10, velocity is increasing by 10, 10, 20, 30, 40. If you get the answer acceleration 30, imagine you get the acceleration 30. That means that velocity increased by 30. If you get the acceleration 40, velocity increased by 40, 40, 80, 120 like that. If you get the acceleration 3, that means velocity increased by 3, 3, 6, 9 like that. How fast the velocity is increasing? If you get a higher value for the acceleration, velocity is increasing fast, rapidly. So what is the SI unit of acceleration? What is the velocity? Velocity measured in V minus U ne? V minus U both velocity ne? So it's ms minus 1. Then time measured in seconds, S. ms minus 1 over S is what? ms minus 2. Meters per square second. It's very important. Some MCQs also they ask this. What is SI unit of acceleration? ms minus 2. Meters per square second. Or else you can write here within bracket. Within bracket write this way also you can write the SI unit. Because there are some other units. Kilometers per hour, meters per minute, kilometers per hours, meters per hours, like that you can express it. But SI unit will be SI unit of length or distance is meters, time is SI unit second. Therefore, within bracket right, this also accepted. M over S squared, that also accepted. But normally we call it meters per square second. Right, meters per square second. So next week I will be doing the calculation. So today I gave only the theory. Change in velocity over time. Change means final velocity minus initial velocity over time. Then the standard symbols I gave. Velocity final V, initial velocity U, time taken T, and acceleration A. So therefore you can calculation in the exam, no need to write the word equation. It is accepted in the exam, no need to define each letter here, right? Okay, very important. Done. Please raise the hand those who are still copying down. Now remember, these days most of the areas there's a power cut nearly 1.5 hours. Now sometimes they will make it 2 hours in the future, but anyway that is not an excuse for not joining the class. Please keep your out. Even that happens to me also, no, but I don't cancel the class. I keep my device fully charged. When the router is off, when the power is not there, when there's a power cut, router is not working, then I have what? Backup. I mean, backup means maybe the mobile device data or somehow I'll manage to do the class without cancelling the class because of the power cut. I have never mentioned in my life there's a power cut, therefore no class today. Never. Last year also I didn't do that. Every year, February to March, there will be a power cut in most of the countries, Asian countries, because of electricity demand increasing. Because hot climate, therefore the most of the people are using maximum, like the fan, usage of air conditioners, AC sale increasing in these few months, right? Therefore the electricity demand is more and the hydropower is less, because water level in the reservoir is going down, hydropower less, demand more. Therefore they supply the demand from the coal or diesel power. Now the problem is the problem here, now the government is lacking enough dollars to import this crude oil or the fuel. Then they can't supply enough fuel to the power stations, and then that's why this power cut again. The other problem, this situation become worse this year than the last few years. Yeah. Now you also should keep your device ready 2 hours with the full charge, so you can manage, no? So at least you can share with your other members, family members device, somehow try to join without, but anyway you can request the recording, no problem. Even if you join the class with the name code, January name code, you can request the recording. If you want to re-listen to this again, you can request the recording with the, so I joined but I want to listen to this, you no problem, you can slowly, leisurely you can do it, right? Okay, then it's almost 8:05. We'll stop for today. Next week I'll do the graphical representation and the calculation part under motion graph, right? Okay, then good night and God bless you all.